Well, students, good morning. Uh, in the previous class, I had given you the discussion after completing the solution chapter. I discussed and give the little bit knowledge about the electrochemistry. Now, before jumping to the definition of electrochemistry, it is better to know how we are able to define and what are the today's learning objective. Let we see, that is introduction. What is electrochemistry? What is the how it is the part of the chemistry? Importance, objective learning. Today's learning objective. This is very important, and this is totally the board method that will depends upon, and it can be practically some experiments can practically be done. Electrochemical cell, and example is galvanic cell. How we construct the electrochemical cell, and what is the working of the electrochemical cell, and what is salt bridge, and what is the function of the salt bridge, and how it is a half cell and complete cell, electrode potential, what is the standard electrode potential. These are the terms to be learned in that today's topics. The standard electrode, and example, that's a standard hydrogen electrode, and another one is EMF of the cell. This is called electromotive force or cell potential of the cell. So before we start the topic, just I want to check the previous knowledge of class 11, and in class 11th we have the knowledge that is suppose a metal, this one zinc, and this is a solid one, and it will loses electron and it converted to this one. What is this phenomena is called? So we know it is very well. This phenomena is called, this is a loss of electron, right? So before coming to the definition, we take, suppose we take a beaker, and in this beaker we take a solution of copper sulfate, and in this we put the rod of the zinc. After some time, this is now copper sulfate aqueous solution. After some time, we touch the beaker and observe our feeling. We see that the beaker becomes warm. It means that during the reaction, some energy is liberated. Now, this energy is liberated, and this is another reaction that happens due to the reaction, and this is called gain of electron, and it is ultimately converted to copper, and there is a gain of electron. So these two reactions takes place simultaneously, and if we add these two reactions, then it will get converted into Zn, copper to copper, this is Zn, copper 2 plus aqueous solid here state, and this one is Zn 2 plus, and this is copper. So what is the redox reaction? So this redox reaction, the reaction in which the oxidation and the reduction both takes place simultaneously, and that reaction is called the redox reaction. So this becomes warm, and it is due to the reason of the redox reaction. So some energy is liberated. Now our aim to design the apparatus to convert this energy, that is the chemical energy, into the electrical energy, right? So this is the apparatus we have to design, and to convert the chemical energy into the electrical energy, and that can be converted into the, suppose we take another example, NaCl, and if melt with This is non-spontaneous reaction. Nothing will happen. Now, if NaCl molten is taken, so it will break up to give Na plus ion, and this is Cl minus ion. When we pass the electricity is passed, so what will happen? This sodium ion will get deposited as Na, and this Cl minus ion get oxidized to Cl2. So we have the two types of the reactions here. One, there is a redox reaction in which the beaker becomes warm, and here this beaker becomes warm is due to some chemical reaction, and this is due to the chemical energy, and we have to design the apparatus in such a way that chemical energy is converted into the electrical energy. And another, this molten NaCl is electrolyzed by passing electric current. It will get the sodium ion get deposited at sodium, and Cl minus is deposited in the form of Cl2. So we come into the chapter. So electrochemistry is the branch of the chemistry that deals with the conversion of chemical energy into electrical energy and vice versa. This is the definition of the electrochemistry. This is the define the electrochemistry. Now, before starting, why we get the knowledge of electrochemistry? Because this application of electrochemistry is very wide, and it is a subject of interdisciplinary subject and wide application. So we get the wider knowledge in the higher classes, right? And what is the applications in our life, we can easily be recognized it. There are so many metals such as sodium, magnesium, etc., and so many compounds such as NaOH, KOH, Cl2 that can be prepared by some chemical method. This is the application of electrochemistry. Another, in our uses, we use the different types of the batteries or the cells, and these are due to in which the chemical reactions are takes place, and we due to the chemical reaction it provides energy, and this is also the applications of chemistry in our life. Another, that it is helps in the transmission of neurosignals from cell to brain and vice versa. And keeping in mind the above application and the wider scope of the electrochemistry, it is need to study here in the class of 12th, right? So what is the electrochemical cell? Just we come here on the electrochemical cell. So what is electrochemical cell? So this example is galvanic cell. Electrochemical cell is a device which convert chemical energy into electrical energy. It is a device, electrochemical cell. Electrochemical cell. It is a device. It is a device which convert chemical energy into electrical energy. In such a cell, the redox reaction takes place in two different compartments, right? As a result of the redox reaction, it will give the energy, and this is the example is galvanic cell. So now we construct the galvanic cell. So it takes much more space. we see galvanic cell. Now we take a beaker, construction of galvanic cell. Galvanic cell. Now we take a beaker and another beaker, and there an electrode is dipped into that beaker, and this is a metal rod. When put in its ion solution, then it will consume the electrode, and this is a zinc sulfate solution, aqueous. And there is a copper rod, and this one is kept in an electrolyte. This is called copper sulfate solution. Now these two electrodes are connected with galvanic cell. These two electrodes are connected with the ammeter or the voltmeter or ammeter. Right? When this is one beaker having zinc electrode kept dipped in zinc sulfate solution, and it is copper electrode kept dipped in copper sulfate solution. We connected it with the help of the wire and having the voltmeter or the ammeter. Will see any deflection in the voltmeter needle? We can't see, because these two reactions, these two electrolytes are in the different compartment. Now, in order to connect these two electrolytes, we use here salt bridge. This is salt bridge. This is salt bridge. And this salt bridge is a U-like tube. This is U-like tube. And it contains inert electrolyte. Inert electrolyte. Electrolyte KCl, KNO, K2SO4, KNO3, etc. with agar. And we put this solution and put into that one. Now after keep it for some time, when it becomes in the paste form, now invert the tube, and this tube is called the U-like tube, and it will act as the salt bridge. This is salt bridge. Salt bridge. This is salt bridge. Now, and in this salt bridge I have taken a solutions of inert electrolyte, meaning to say inert electrolyte means that electrolyte that do not react with the electrolyte present in the left compartment and the right compartment. Now when we insert the electrolyte salt bridge, we see immediate deflection into the galvanometer. So this is the construction. Now working of this cell. Working. Now this is left side, this is right side. What happened? Now in the left side, the zinc metal will lose electron and get converted into zinc ion. That comes into the zinc ion. This electron free that travels with that wire now and deposited in the right compartment. In the right compartment, this copper ion that obtains from the copper sulfate solution, this copper sulfate solution when break up gives the copper ion and the sulfate ion. So this copper ion get reduced by taking the electron, and this is twice electron, and this is called the copper, and here the process of reduction, and here the process of oxidation. Another thing, add it lose electron and it gain of electron. due to loss of electron, it is called due to loss of electron, it is called negative electrode. So we put here the negative sign, and due to gain of electron, it acts as a positive electrode. So we put the positive sign here. Now, and this negative electrode is known as anode, and this positive electrode is called as cathode. So there is a simple way to represent the cell, and that should be correct one, that is LOAM, LOAM. So you will remember, this is for our memory, that we don't commit any mistakes. L for left, O for oxidation, A for anode, and for negative electrode. So the opposite in the right side. So what is the opposite of left? That is right. What is the opposite of oxidation? That is reduction. What is the opposite of anode? That is cathode. And what is the opposite of negative? That is positive. That's why it is called the positive electrode. So in the redox reaction, the electrode sign convention is just different than that of the electrolytic cell or electrolysis cell used for the electrolysis, where we take as anode as positive electrode because it is connected with the positive terminal of the battery, and negative cathode, it is connected with the negative terminal of the battery. But at that electrode, the process of reaction, that is oxidation and the reduction, that will remain the same. At anode, always oxidation will take place, and at cathode, always reduction will take place. So this is the construction, and this is the working. Now, when we insert the salt bridge here, then what will happen? We see the deflection in the voltmeter. Now, the electron will flow from this side and that side. So, we never see the flow of electron. We simply see the flow of the current. The current will flow from that side to this side. So, this is known as the how it works. Now, even when the salt bridge removed away, then what will happen? No deflection in the voltmeter or in the ammeter. Then this salt bridge plays a vital role. So what is the functions of the salt bridge? Let us to study here function of salt bridge. Function of salt bridge. This is very important. First function, it allows the passage of electric current by completing the circuit. First point is, it allows the passage of electric current by completing the circuit. And another one, circuit. And another, it maintains electrical neutrality. It maintains electrical neutrality. Electrical neutrality. Electrical neutrality. It maintains the electrical neutrality. Now, so how it allows the passage of electric current? We simply explain it. That is, when it is removed, no deflection. When it is inserted, then we see the deflection in the voltmeter. It means that salt bridge helps to connect the two electrolytes that are kept in the separate beaker. This is called the indirect redox reaction. That can happen possible with the help of that salt bridge. Now another, how it maintains the electrical neutrality. This is very important. Here zinc will lose electron, so it will get deteriorated, and zinc will lose electron and convert into the zinc ion. Now the electron will flow through that wire, and here it comes to in the copper will accept electron, and it will get converted into the copper. So what will happen in the left compartment? the concentration of zinc ion will increases. This zinc ion concentration will increases, and in the right compartment the concentration of sulfate ion increases. This is increases because here is sulfate ion, all copper ion is get converted into the copper, so they will deposited over this rod. Then what will happen? So there is a negative ion and there is a increase in the concentration of positive ion. So the salt will have the Cl minus and K plus. If we have taken the KCl solution as electrolyte in the salt bridge, then what will happen? It move in the opposite direction in order to neutralize the increased concentration of positive ion and the negative ion. So here the negative ion concentration increases, so K will move in that compartment, that is right side, and the Cl will move in the left side, so that the concentration of the zinc ion which was increased becomes neutralized, and the cell will again work. This is the applications of the salt bridge. Now, so another concept. So this is the cell, and if the two half cells are, this is called the half cell. So the reaction is Zn solid, and this one is Zn2 plus aqueous. Always the state should right, and in the right side, this is in the left. So this one is oxidation. Here there is a loss of electron, is always written in the right side, and there is copper 2 plus ion, it gain electron and converted to copper solid, and this is the reduction, and this is the right side. So this is half cell, this is called half cell, and this one is also called the half cell. So if in the examination, if asked to write the half cell, this is the half cell. If asked that half cell is responsible for the flow of electric current, then what we say? That a half cell is not responsible for the flow of electric current, because for the flow of electric current there should be the potential difference. If there is no potential difference, then no questions of the flow of electric current. So if we combine these two, Zn solid one, and this copper 2 plus aqueous, here is aqueous sign, always keep the state, write the state, and this one, and this is copper solid. So this is called a complete cell reaction. Complete cell reaction. Cell reaction. This whole reaction is called the redox reaction. Due to that redox reaction, it will flow that chemical energy is converted into the electrical energy. So complete. Now what is the cell representation? Our question is cell representation. Cell representation. Presentation. How we will represent the cell? So what will happen? Zinc is dipped in zinc sulfate solution, zinc 2 plus aqueous, and the copper ion get reduced to what? This is copper solid. So erase it completely. That looks fresh. So this is copper, this is solid, aqueous solution. Now this is a half cell, and this is a negative electrode, and this is a positive electrode. Why negative? Because due to oxidation, it loses electron, that's why it is negative. And why it is positive? Because it gains electron, that's why it is considered as positive. So these two half cells are connected with the help of that salt bridge. So this salt bridge is represented by a double parallel line. So this is the representation of that cell. The whole diagram is represented in this way. This is called the representation of the cell. So question is asked, the electrode potential is given, right? And by using that data, you have to represent the electrochemical cell. Suppose question is 0, copper 2 plus, it will be discussed later on. copper, that is plus 0.34 volt, and E0 Zn2 plus, and this is Zn, it is equal to minus 76 volt. So there is a theory behind that. The metals which has, or the element, the metal which have the negative reduction potential value, more tendency to lose electron and get oxidized, and the metal which have higher reduction potential value have more tendency to take up electron and get reduced. So by using that data, the higher the value that is written in the reduced form in the right side. So it is written in the right side, and obviously in the left, here the value of reduction potential is given, but in the left oxidation will take place, so zinc will get oxidized to zinc ion. By that value, this is the representation of the cell. So there are so many values are given. You have been asked to represent the cell. This is the way, and if asked, write the half reaction, we can write like that way, and it is the half reduction half, oxidation half, and the total reactions. Now, the condition arises here. There are three figures in this. So before going to the figure, it is taken as a EMF of the cell. So it can be, there are three conditions. This is simple figure I will take. In one figure, this one, this is a salt bridge, and this one is connected with a voltmeter. This is a zinc electrode, and this one is copper electrode. Now this is connected with this one, that is the figure, this is, and this one, this is external potential is applied here, and this external potential, this is connected like this, this one. So there is a condition, all the figures are given in the book. We have the condition first. When E external is less than E cell, right? So when E external is less than E cell, then what will happen? When, another condition, when E external is equal to E cell, means cell potential of the cell. And the third condition, when E external or is greater than E cell. This E cell called the cell potential of the cell. This is called cell potential of the cell. This E cell is called cell potential of the cell. Or this is called EMF of the cell, electromotive force. And this EMF is calculated as E cell is equal to E cathode minus E anode. So EMF of a cell is defined as, it is the difference of electrode potential of the cathode and the anode, or the reduction potential of the right hand electrode and the left hand electrode. Now this value, it is written in the standard reduction potential. This is called the standard reduction potential of left right hand electrode minus a standard reduction potential of left hand electrode, this one. So this value in the right side copper is used, and its value is 0.34 there, and this is the value of minus 0.76 volt, and now it is calculated 1.10 volt it comes. So this is here the cell potential of the cell. If E cell is greater than that of the, there are three conditions. What are the conditions? when external potential is greater than that of the E cell, then what will happen? So here what will happen? The cell potential is calculated 1.10 volt. So when it comes, what does it mean? That is, zinc will dissolve and electron flow zinc to copper and current flow from copper to zinc. Condition is given external is greater than that of cell potential. So current will flow from. The reaction will just reverse. So what will happen? So what will happen in that situation? Here zinc and here the electron will flow from. Electron flow from where? Copper to zinc. Copper to zinc. Current will flow. Current will flow zinc to copper. Zinc to copper. First condition. Now, which one get dissolved? This is which one get dissolved? Copper get dissolved. Here, copper get dissolved. May I write here? This is. So for here, this copper will dissolve. Another copper will dissolve and zinc deposited. And what is happens here? External potential is less than E cell. So what will happen? First, electron flow from zinc to copper. Current from copper to zinc. And here zinc will dissolve copper deposited at copper negative. So there are two conditions. How we calculate the E cell, that is cell potential of the cell. So condition, there are three conditions, all three conditions with figure given in your book like that. This is the external potential. And there are three conditions when external potential is greater than E cell, when external potential is greater than that is E cell. And the third condition, this is the third condition, suppose E external potential is equal to E cell. Then what happen? No flow of current, no deposition of the, no flow of current and no chemical reaction. So this is no flow, no flow of current. This is the three conditions given with figure in your book. You will see these three conditions are very important. So this is galvanic cell, representation of galvanic cell, half cell and the complete cell and this one. Now we come on the electropotential. Another points I would like to discuss. This is electrode potential. What is electrode potential? Electrode potential. Electrode potential. So when a metal is kept dipped in its ion solution, it will constitute the electrode, and the potential difference set up between the metal and the electrolyte. This is electrolyte. This is called the electrode potential. Potential difference between the metal and its electrolyte. The solution is called the electrode potential. Now What is the standard electrode potential? And what is the standard electrode? First we know the standard electrode. The electrode which is set up at standard condition, by maintaining the standard condition, then that electrode is called the standard electrode. Suppose hydrogen is a gas. Now the question arises how we set up the hydrogen electrode. Now we take a platinum wire. This is and this is designed in such a way. This is a platinum wire, PT wire. This is a standard electrode example, hydrogen electrode. Now we take. So this is a platinum foil coated with platinum black. And it is kept in a electrolyte, suppose HCl, whose concentration is 1 m, and this hydrogen gas is passed here at 1 atmospheric pressure, H2 gas pressure 1 atmosphere. Pressure 1 atmosphere. Now this is a platinum black coated with platinum foil coated with platinum black in order to increase the surface area for the adsorption of the hydrogen gas when it is bubbled by that pipe. So here the electrolyte. So the electrode setup, this is PT and this is H2 gas and this one is H plus. Sometime, and this is also written as, so this is the standard electrode and the example is a standard hydrogen electrode. Why it is called the standard? Because it is set up at a standard condition. And what are the standard condition? The concentration is taken as 1 m and the hydrogen gas is passed at 1 atmospheric pressure, and the that is temperature is kept at 298 Kelvin, and that electrode is known as the standard electrode. So standard electrode potential. The standard electrode potential. Now the another part is a standard electrode potential. A standard electrode potential, and this is called the reduction potential. Generally we call it standard electrode potential. If the concentration of the ions in each half cell is taken as unity, then that electrode is called the standard electrode potential. If concentration of ions in each half cell is unity, then called standard electrode potential. Right? This hydrogen electrode is another way. Standard electrode potential can also be defined, because the electrode which is used to determine the electrode potential of a unknown metal electrode is known as the standard electrode potential. Suppose you invite a friend to come at your home, and you have given a reference point that certain, that is museum is there, and in front of museum my house is there. So your friend go to your address with the reference of the museum. Now suppose you give the reference point, when you will see the rickshaw standing at the road, on the road, then it will be my house. When he started his journey to reach your home, and he will show so many rickshaws are standing on the road. So that is not the reference electrode. So reference whose electrode potential is known, whose value is known, and whose place is known to all of us, and that electrode is called the reference electrode. So sorry. So here this hydrogen electrode is taken as the reference electrode because its electrode potential, standard electrode potential value is known. This value is 0.00 volt. This is 0.00 volt. And with the help of this standard hydrogen electrode, we are able to find out the electrode potential of the unknown metal electrode is known as the reference electrode. Now, this is the reference electrode. Or now this hydrogen electrode whose electrode potential is known, now used to determine, suppose we take here this is act as this hydrogen S2 electrode, simply we can write acts as anode and as well as at cathode, दोनों की तरह ये काम करता है. This will act as anode as well as it will act as cathode. How it will act as, when it will act as anode, this is Pt and this is H2 and this one is H plus ion. And when it will act as cathode, H plus, and this is H2 and this one is Pt. So for the sake of simplicity, we take it as this is the hydrogen electrode. We connected it with the electrode. Now here suppose we zinc, and again it is connected with this one. Now the salt bridge is added, and we measure the E cell, and this E cell comes to be this is 0.76 volt. Now, but how will represent this cell? You see simply, this is zinc. Now this is zinc sulfate solution. This is zinc sulfate solution. So what we will see here in that compartment, this is written as Zn, and this is Zn2 plus, and this is salt bridge, the salt representation, and this one is reduction, and here the reduction is here. This is H plus, and this is H2, and this is P2, because P2 is a noble metal. That's why it is used as a electrode for setting up the electrode, because the noble metal do not react with. So this is that. Now E cell is this E cell. So for that we can write here E cell. For this side we can write E cell is equal to E cathode minus E anode. So what is in the cathode side? This is E0 H plus H2. What is in the anode side? We use the zinc electrode. So this is Zn2 plus and this is Zn. So E cell comes to be 0.76 volt, and its value is known. It is 0, and it comes to be this is equal to minus E0 Zn2 plus and this is Zn. So E0 Zn2 plus Zn is equal to how much? 0.76 volt. So you see, what is the role of the standard hydrogen electrode? It is called normal hydrogen electrode or called a standard hydrogen electrode. It will act as a reference electrode. With the reference of that electrode, we are able to calculate the electrode potential of a unknown metal electrode, that is the zinc electrode. So here the zinc electrode value comes to be 0.76 volt, and this is the cell representation. This is the cell, and this is the salt bridge. Now this is the representation of this cell. This is the representation of this cell. So this is the representation of this cell. Now in this time it will act as cathode. This is cathode, and sometime it will also act as anode. So acts as anode. You see, Now suppose the hydrogen electrode is this side. In the simple way I write it. This is hydrogen electrode, H2 electrode, and there another, that is copper metal is there, and this is a copper sulfate solution. Now it is connected with salt bridge. Now these two electrodes are connected with voltmeter, and cell potential is measured and it comes to be 0.34 volt. Then what will happen? We write here E cell barabar E cathode minus E anode. E anode. So what will happen here? This is in the cathode side, E0 copper 2 plus, and this one is copper. And what is here? This is E0 H plus and this is H2. Because here this is the hydrogen that is in the left side, this is minus and this is on the plus. E cell is 0.34 volt, and this value, this is E0 copper 2 plus copper, or this one is 0.0. So what it comes? That is copper 2 plus copper, so plus 0.34 volt. So it means with the reference that a hydrogen electrode, which will act as, here it will act as cathode and here it will act as anode. So this is the role play of the standard electrode to determine the electrode potential of the unknown electrode. So now we just now to conclude what happened, what we learned today. What is the electrochemistry and what is the electrochemical cell, and how electrochemical cell is constructed, and it is a redox reaction, and what is the functions of the electrochemical cell. It converts chemical to electrical energy, and we use to connect it via salt bridge. And what is the functions of the salt bridge? We are able to say the functions and this one. Now this is the cell representation and electrode potential, a standard electrode, a EMF of the standard electrode, and we calculate the cell potential of the cell, and this is called the electromotive force of the cell. EMF of the cell is defined as the electropotential difference between the two electrodes, right? So this is the EMF of the cell, and it is calculated, and we have the three conditions when external potential applied on that cell is greater than the cell potential, less than and equal to 0, and there are three conditions are given in your book with figure. You can clearly you show this figure there. And how will a standard electrode, we take an example of the hydrogen electrode and we consume the hydrogen electrode by maintaining the standard condition. And this hydrogen electrode will act as a reference electrode because its electrode potential value is known, and its electrode potential value is 0.00 in the electrochemical tree. So the electrochemical trees in the electrochemistry has a wide applications. Now this electrode, hydrogen electrode, is used to determine the electrode potential of the zinc and the cadmium electrode, and we have seen and calculated it, and I hope when you will go through this topic and you will consult the book, and that lecture helps you to understand what is written in the book. Thanks a lot. यदि आपको ये लेक्चर अच्छा लगा तो आप इसको शेयर करिए और क्या कहते हैं उसको लाइक करिए या शेयर करिए मैक्सिमम, तो फिर हमें इंस्पायरेशन होगा और हम आगे क्लास में दूसरे लेक्चर के साथ आपसे मिलेंगे. थैंक्स ए लॉट फॉर योर पैशंस लिसनिंग. थैंक्स.